Good day, math learners! I'm back. In this topic, we will discuss about measures of variability. Variation in scores. The results of a 20-item test show the following sets of scores for the two classes, which each with 10 students. Okay, this will be the given data. 8 honesty. Those are the scores of the 8 honesty section. For the 8 unity, that will be. Now, the question is, in what ways are the two sets similar? Or the two given sets are similar? In what ways are the two sets are different? Based on the scores, which section performs better? We will see. In the given situation, both classes have the same mean, and that will be 13. Since the two sections have the same mean, we cannot identify easily which section performs better. Okay, how to get the mean? Remember, in our past discussion, you will add all the values, then divided by the number of data. So if we add up 5, 7, 12, 14, 14, 15, 15, 15, 16, 17, then divided by 10, the result is 13. And they are similar, the same mean. Same if you add 11, 11, 12, 12, 12, 13, 14, 14, 15, 16, divided by 10, the result is also 30. That's why they have the same mean. In grade 8, unity, the scores are more clustered together, with a score at 16 and the lowest score at 11. Hence, we say that there is among the scores of the students of grade 8 honesty than in grade 8. So they are grade 8 unity performs better than grade 8 honesty performs better than in grade 8 unity. Measures of variability. Two or more sets may differ from each other, not just in their central tendency but also in the spread of the scores over the scale of measurement. When we say variability, it is a reflection of the individual differences between the people and events being investigated. When we say measures of variability, it describes how large the difference between individuals are on a trait. It's sometimes referred as a measure of dispersion. It refers to the spread or disperse of values about the mean. And last, that of the lowest or the low values of these measures means that the distribution is less than dispersed and clusters closer to mean, while high values will be greater dispersion. The measures of variability of the spread values about the mean can also provide additional information about the data. Consider another example. The number of toys produced by 16 workers in factory A and factory B. This will be the given data for factory A and for factory B. The mean production of a factory A is sum of production over 16 is equal to 10.625. The mean production of factor B, if we add up all the sum of production over 16 with the number of data, and that is equal to 10.625. As you can see, they have both they have the same mean. These two distributions differ in spread. The highest and the lowest productions in factor A are 15 and 8, respectively, while the highest and lowest productions in factor B is 12 and 9. Note that the variability of dispersion of the mean is less than factor B than in factor A. Range. To get the value of the range, the formula is highest value minus the lowest value. Consider the following example. The number of toys produced by 16 workers in factor A and factor B. Okay, same data. To get the range of the factor A, highest value of factor A is 15 and the lowest value is 8. So that's why 15 minus 8 equal to 7. For factor B, 12 minus 9. 12 minus 9 is equal to 3. That will be the range of our factor A and our factor B. Notice that the highest and the lowest production in factor A are farther from each other, and it is compared to the highest and lowest production in factor B. The range is easy to compute, but it is a less convincing measure of variability, because it is usually used in the extreme values. This tells nothing about the spread of data between the extreme values. Now for the average deviation. When you say average deviation or mean deviation for ungrouped data, it is the average of the sum of the difference of each measure from the mean regardless of the sign. The value of the average deviation indicates the spread or the variability of the data. A large value means the observations are widely spread or scattered about the mean, while small value means that the observations are quite close to the mean. In symbol notation, the formula for the average deviation of ungrouped data is, this will be the formula for average deviation, the summation of x minus the mean over n. So we need to find the value of the summation of x minus the mean so that we can compute the average deviation. Because n is already given, because n is the total number of data. Average deviation or the mean deviation, x is the given value, that will be the mean, n is the number of measurements or the number of data. Example number 1. The table shows the number of toys produced by the two factories. Compute for the average deviation of each data. Okay, same data, factor A, factor B. Okay. For factor A, first thing we need to do is we need to solve first factor A. Step 1. Find the total number of values and n and solve for the mean of the given data. Okay, this will be factor A, the given for factor A. We need to find the mean of this data. To get the value of mean of ungrouped data, in our past discussion, we will add all the values of x. So 8 plus 9 plus 9 plus 9 plus 9 plus 9 plus 10 plus 10 plus 10 plus 11 plus 11 plus 11 plus 12 plus 13 plus 14 plus 15. Okay, or you can also add directly from the given. Don't need to arrange if you want to get the mean over n, which is 16. The sum of all the values of x, that will be 170 over 16. 170 over 16, your answer must be in nearest hundreds, or we will use 2 decimals. Okay, round off your answer into 2 decimal places. So your answer is mean is equal to 10.63. Step 2. Add 2 columns with the deviation and the absolute deviation. Please remember the values or the value of our mean because we will use that one. So additional column, that will be the x minus the mean, and the second column that is added, that is the absolute value of x minus the mean. Step 3. Solve for the values in the third column, which is the deviation or the difference of the values and the mean. Okay, we will subtract the values of x minus the mean. It's just simply 8 minus mean, that will turn to a negative 2.63. 9 minus 10.63, that will be negative 1.63. Same. 10 minus 10.63, that will be negative 0.63. Okay, same. 11 minus 10.63, that will be 0.37. So 311, they are same answers. For 12 minus 10.63, that will be 1.37. 13, 2.37. 14 minus mean, 3.37. 15 minus the mean, 4.37. Step 4. Solve for the values in the fourth column. That will be the absolute value of x minus the mean. Even your answer is negative in the x minus mean table, the answer is always positive because of the absolute value. Okay, from negative 2.63 turn to positive. All the negative values here will turn to positive. All the positive values here will remain positive. Step 5. Find the sum of all the absolute deviations. So we will sum all of this one. We will add all the absolute value. That will be the summation of all this value is 25.26. Okay, if you add all the values for this one, that will make into 12.26. Step 6. Use the formula to solve the average deviation. Average deviation is the summation of x minus the mean, or summation of absolute value of x minus the mean over n. So, substitute the value of the summation of absolute value x minus the mean, that will be 25.626. And our n is 16, and rounded off to the nearest hundreds, or use 2 decimal places for our final answers. That will be AD, or average deviation, is equal to 1.58. For our factor B, we need to solve for the average deviation for that. The given data for factor B. Step 1. So we need to get the value of mean, same process. So we add all the values of x here, then divided by 16. So the total for this one is 170 divided by 16. Run off your answer to the nearest hundreds using your calculator. So 170 divided by 16, that will be 10.63. Step 2. Add two columns, same, x minus the mean, and other column, absolute value of x minus the mean. Step 3. So you subtract the value of your x minus the mean. So 9 minus 10.63 is negative 1.63. Same. 10 minus 10.63 is negative 0.63, so same. 11 minus 10.63, that will be 0.37, so same result, 11. 12 minus 10.63, that is 1.37. Step 4. Make all the values positive because of this absolute value. So, all the negative numbers here will turn to a positive number. All the positive values here will remain as positive. Okay? Step 5. Find the sum of all the absolute deviations of the summation of absolute value x minus the mean. Okay? It means that you will add all the absolute values here. Okay, and that will be our summation of absolute value of x minus the mean, and that will be the total of 14. Step 6, that's the time we will use the formula to solve the average deviation, because we already have this answer, or we already have the summation of the absolute value x minus the mean and the value of n. Okay, using this formula, we substitute all the values here. So That will be 14 for the summation of x minus the mean, absolute, and n is 16. So the 14 divided by 16, that will be 0.88. We need to round off our answer to the nearest hundreds. So we concluded that the average deviation of factors A and B are 1.58 and 0.88 respectively. Since the average deviation of factor B is lesser than the average deviation of factor A, it means that the distribution of factor B is less dispersed and are closer to the mean than factor A. The lesser the dispersion, the better. Please take note for that. Again, the lesser the dispersion, the better. Thanks for listening. Don't forget to answer the given formative assessment. And also don't forget to click and subscribe. Thank you.
Hello Math learners! In this video, we are going to continue discussing the other measures of variability. And these are the standard deviation and variance of ungrouped data. But before you will watch this video, make sure that you have watched already the video about range and average deviation, because this video is just a continuation of the first video. So let's begin. What is standard deviation? When we say standard deviation, it is the measure of the variation of a set of data in terms of the amount by which individual values differ from their mean. It is considered the most stable measure of spread and is usually preferred in experimental research studies, where in-depth statistical analysis of data is involved. In symbol notation, the formula for the standard deviation of ungrouped data is standard deviation is equal to the square root of the sum of all values of x minus mean squared divided by n. SD stands for standard deviation, x stands for the given value, next this stands for mean, and n stands for the number of measurements or values. So now let's have the steps in finding the standard deviation. So these are the steps in solving for the standard deviation of ungrouped data. Step 1. Continue the table used for average deviation and add one column for the quantity of x minus mean squared. Now, it's better that you know already how to find the average deviation, because it's easier for you to find the standard deviation just by continuing the table you used in finding for average deviation. Step 2. You solve for the values of the quantity of x minus the mean squared. And step 3. Find the sum of all the values in the fourth column. So that means you will add all the values of x minus mean squared. And then the last step, use the formula to solve the standard deviation. Now, let's continue the table that is used in the average deviation and solve for the standard deviation. So again, here is our example. It is a table that shows the number of toys produced by two factories. Let's compute for the standard deviation of each set of data. So again, this is our given example, the number of toys produced by 16 workers in factory A and factory B. Now let's solve first for the standard deviation of the first factory, factory A. Okay, so to solve for the standard deviation of factory A, it is really important that you know the table that was used for the average deviation of factory A. So you can see this table in the previous video, the first video, which talked about the range and the average deviation of ungrouped data. Now let's start solving for the standard deviation of factory A. So step 1, continue the table used for average deviation and add one column for the quantity of x minus mean squared. So we will just draw one column here, and the column header would be x minus mean squared. Step 2. Solve for the values of x minus mean squared. The values in this column are just the square of x minus mean. And actually, we already have the values of x minus mean. We can see those values in the second column of our table, x minus mean. So, to get the values of the fourth column, we are just going to get the square of the values of the second column. And when we say square, it means we need to multiply it by itself. So for example, negative 2.63 squared It is negative 2.63 times negative 2.63, and that is equal to 6.92. Next, negative 1.63 squared. It is equal to 2.66. Since they are the same, so they have the same squares. 2.66, 2.66, 2.66, 2.66. Now, we have here negative 0.63. If we are going to square this, the answer is 0.40. Make sure to round off your answer to 2 decimal places. Next, still 0.40 and 0.40. Now, 0.37 squared. The answer is 0.14. 0.14, 0.14. Now, 1.37 squared. The answer is 1.88. Next, 2.37 squared. The answer is 5.62. And 3.37 squared. The answer is 11.36. And the last one, 4.37 squared. The answer is 19.10. So we are done with step 2, which is solving for the values of the fourth column. Now, step 3. Find the sum of all the values in the fourth column. So we are going to add all these values right here and write the sum at the lowest row. So we can write here the sum of the quantity of x minus mean squared. If we are going to add all these values, the answer is 59.8. So we are done with step 3. Step 4. Use the formula to solve the standard deviation. So this is the formula. We are just going to copy that. Standard deviation is equal to the square root of, we are now going to substitute the values. So the sum of x minus mean squared, this is the sum of the values of the fourth column. So we have here 59.8 divided by the value of n. And our value of n is 16, so we can just write 16 here. Now, using our calculator, let's solve for the square root of 59.8 divided by 16. So, the answer is, standard deviation is equal to 1.933261499292. This is not yet our final answer because we can see many decimal places, so we need to round off our answer to only 2 decimal places. So our final answer would be standard deviation equals 1.93. So this is the standard deviation of the first factory, factory A. Now, let's solve for the standard deviation of the second factory or factory B. So again, we need to know the table that was used in solving for the average deviation of factory B, because step 1 is to continue the table and add 1 column. So again, the fourth column would be the quantity of x minus mean squared. And to get these values, we need to square the values in the second column. So we need to square negative 1.63 squared is 2.66. Since they are the same, so they also have the same squares. So 2.66. Now, 0 or negative 0.63 squared, the answer is 0.40, 0.40, 0.40, 0.40, next, still 0.40. Now, 0.37 squared, the answer is 0.14, so we are going to write the square, 0.14 and 0.14. Last, we have 1.37. 1.37 squared is 1.88. So, this is 1.88, 1.88, and still 1.88. We are done with step 2, which is solving for the values of the quantity x minus mean squared. Step 3. Step 3 is to add all the values in the fourth column. So if we are going to add the sum of the quantity x minus mean squared is equal to 15.8. So done. Now step 4. use the formula to solve the standard deviation. So again, this is the formula to be used. Copy first, standard deviation equals the square root of the sum of the values in the fourth column, and that is 15.8 divided by the value of n, and that is 16. Using a calculator, we can get 0.993730.34571. We need to round off our answer to 2 decimal places, so our final answer is 0.99. This is the standard deviation of factory B. So we are done solving for the standard deviation of both factories, so we can now have our summary. The standard deviation of factory A is 1.93. The standard deviation of factory B is 0.99. Now, since factory B has a smaller value than factory A, the values of factory B are more closely clustered about the mean. So this is the interpretation based on the standard deviation. Now, let's solve for variance. What is variance? This is the last measure of variability. And the variance for ungrouped data is just the square of the standard deviation. In simple notation, the formula for the variance of ungrouped data is the variance equals the sum of x minus mean squared divided by n, or variance is just the square of SB, or standard deviation. Let's have the steps. There's only one step in solving for the variance, and that is to continue the table used for standard deviation and then find the square of the standard deviation using this formula. So let's continue the example. Let's solve first the variance of factory A. So to solve for the variance of factory A, we just need to continue the table used in solving for the standard deviation of factory A. So again, we have here the standard deviation, which is equal to 1.93. And we all know that the formula for variance is just the square of the standard deviation. So we are just going to square 1.93. So this will become variance equals 1.93 squared. And the answer is 3.7249. But since we need to round off our answer in 2 decimal places, our final answer is 3.72. Now, let's solve for the variance of factory B. So again, this is the table that was used in solving for the standard deviation of factory B. So we are just going to continue this table by using the formula variance equals SD squared. And the value of the standard deviation is 0.99. So this will become variance equals 0.99 squared. And if we are going to square 0.99, the result is 0.9801. Now, we need to round off our answer in 2 decimal places. So this will become 0.98. So the variance of factory B is 0.98. Now, let's compare the variance of the 2 factories. In factory A, we have 3.72. In factory B, we have 0.98. Since factory B has a smaller value than factory A, the values of factory B are more closely clustered about the mean. Now, let us have the summary of the measures of variability of the given example. We have here again the number of toys produced by 16 workers in factory A and factory B. So, after finding all the measures of variability, we have here the range. In factory A, 7, factory B, 3, average deviation, 1.58 and 0.88, standard deviation, 1.93 and 0.99, and the variance, we have 3.72 and 0.98. Based on the table, factory B has lesser values of variability than factory A. The distribution of factory B are less dispersed and are closer to the mean. Therefore, factory B performs better in producing toys than factory A. So that's all for this video. Thank you so much for listening. Always remember, the only way to learn mathematics is to do mathematics.